We're living through a massive revolution right now. It's a revolution built on two things: artificial intelligence and the tiny little silicon chips that actually give it life. These two forces are locked in what you could call a trillion-dollar dance. And today, we're going to take a look at the 2025 forecast for the semiconductor industry to see where the next steps are going to lead.
I mean, that's a pretty bold statement, right? But it's becoming more and more true every single day. Just think about it. From healthcare and engineering to how we create movies or music, AI isn't just some tool anymore. It's becoming the foundational layer for this next huge wave of innovation, basically reshaping entire industries from the ground up.
And if you want to understand the sheer scale of this transformation, look at this number. The global AI market is projected to skyrocket to nearly $1.8 trillion by 2032. That's not just growth, that's a seismic shift in the global economy, and pretty much every single dollar of that is tied to what we're talking about next.
Which of course leads to the crucial question, this massive trillion-dollar world of AI. It's all digital, but it's not imaginary. It has a physical foundation. So what are the actual nuts and bolts that are making all of this possible?
Well, the answer is silicon. This right here, this is the projected sales figure for the semiconductor industry in 2025. Almost $700 billion. Every single advancement in AI, every new algorithm, every large language model, it all runs on these chips. The two are completely inseparable.
Okay, so let's break down where that incredible growth is really coming from. Because while the whole industry is on the rise, the real engine is generative AI. And what's happening is it's creating this fascinating split in the market.
Now this is where it gets really interesting. Check out this paradox. In 2024, chip revenues shot up by 19%, which is fantastic, right? But at the exact same time, the actual number of silicon wafers being shipped went down. So how is that possible? Well, it tells us something huge. The industry is selling fewer chips, but the chips they are selling are much more valuable. We're talking about those high-performance chips that GenAI desperately needs.
And this chart, wow, it perfectly illustrates that tale of two markets we just mentioned. On one side, you've got the companies that are deep in the generative AI boom. Their value exploded by an incredible 93% in just 1 year. But on the other side, companies focused on more traditional stuff like chips for cars or standard smartphones, they grew at a way slower pace. AI has become the clear dividing line between incredible growth and just business as usual.
And if you need any more convincing about the scale here, just listen to this from AMD's CEO, Lisa Su. She's predicting that the market for AI accelerator chips alone could hit $500 billion by 2028. Now, to put that in perspective, that is more than the entire semiconductor industry's sales in 2023, the whole shebang. It's a truly mind-boggling forecast.
So here's where this whole relationship gets really fascinating. It's almost a sci-fi twist. It's becoming a feedback loop. See, AI isn't just a consumer of chips anymore. Now, AI is actually helping to design the very next generation of chips that will power it.
A huge part of this is a concept they call the shift-left approach. Now, designing a chip is incredibly complex. Traditionally, you might find a major error late in the process, which costs a fortune to fix. Shift-left, which is supercharged by AI, is all about moving that testing and validation way earlier in the process. It's about being smarter, faster, and catching those tiny problems before they become million-dollar catastrophes.
And this new playbook is a total game changer. First, AI is optimizing for incredible efficiency. We're talking about squeezing every last drop of performance out of each watt of power. Second, designers are using digital twins, perfect virtual copies of the chip, to test and refine them in cyberspace. This saves millions in physical prototypes. And finally, security isn't just an afterthought anymore. It's being woven right into the chip's DNA from day one.
But all this amazing technological speed is running headfirst into a very human bottleneck. The industry is facing a massive talent shortage that could honestly slow everything down.
And the number itself is pretty stark. The semiconductor industry needs to find and hire 1 million skilled workers by the year 2030, just to keep up with demand. That's over 100,000 new people, from engineers to technicians, every single year.
And the problem has a bunch of layers. You have an aging workforce that's starting to retire, which creates this huge experience gap. At the same time, you've got these big efforts to bring chip manufacturing back home to the US and Europe, which creates these intense new pockets of demand for skilled labor. And the result?
We're seeing multi-billion-dollar factories facing delays, not because of the technology, but because they can't find enough people to run them. It's turned into a global scramble for the best talent.
So on top of the talent problem, there's another massive challenge, the supply chain. And this isn't just about logistics anymore. We're talking about a global chessboard where technology, economics, and geopolitics are all colliding.
A key strategy shaping this whole landscape is what's being called the small yard, high fence approach. So what's the idea? Well, instead of these huge, broad restrictions, the US is targeting a very specific, narrow set of the most advanced chip technologies. That's the small yard. And then they're putting extremely tight controls around them. That's the high fence. This is all aimed squarely at technologies that could have military uses.
And as you can see from this timeline, this situation is not static. It's escalating. In late 2024 and early 2025, we saw this rapid-fire series of actions and reactions. You had new US restrictions on equipment, then China fires back with restrictions on key raw materials. Then the US comes back with even more rules on AI tech. This kind of back and forth is the new reality.
But geopolitics isn't the only risk out there. Take a look at this. This chart shows that a staggering 75% of the entire world's DRAM memory, which is a critical component in basically everything with a plug, is made in just one country, South Korea. Now, that kind of concentration creates huge vulnerabilities. The whole global supply chain is at risk of any kind of disruption, whether it's political, economic, or even a natural disaster.
Okay, so let's pull all of this together. Looking ahead, what are the key signposts we should all be watching for in 2025 and beyond? What are the biggest risks and the most exciting opportunities on the horizon?
So here's what to keep an eye on in 2025. There are 5 really big things. First, something called the monetization gap. Are companies actually making money on these huge AI investments? Second, the startup surge. We're seeing a ton of small, agile players challenging the big guys. Third, keep an eye out for mergers and acquisitions as the market consolidates. Fourth, those geopolitical headwinds aren't going away. And finally, number 5, the AI domino. Because right now, AI spending is propping everything up. If that slows down, the entire industry is going to feel it.
And all of that leaves us with one last kind of mind-bending thought to take with you. We've talked about a world where AI is helping to design its own hardware, creating this self-accelerating cycle of innovation. And as that loop gets tighter and faster, you really have to ask yourself, who or what is truly in the driver's seat of this whole thing? It's a question that's probably going to define the next decade of technology.